Hello everyone, today we are going to discuss the fourth problem of AtCoder beginner contest 331, which is tile pattern. So we are given a massive grid of 10 to the power 9 by 10 to the power 9, and we are also given a smaller grid P of n comma n. So let's consider we have given a smaller grid P of n cross n, and we are also given a massive square grid A of 10 to the power 9 to 10 to the power 9, and this cells of A is mapped by this pth cell. Okay, so Aij is nothing but Pi modulo n and J modulo n. So this is the problem statement. I am trying to explain the problem statement first. Now we are also given q queries, and in each query we are given four integers a comma b comma c comma d. So these integers are nothing but indices, like points in the a matrix. This is a matrix. So we are given top left cell of some rectangle and top right cell in the some rectangle in a, and we have to find the number of total number of black cells contained in the rectangle. Okay, so you have to find the total number of black cells contained in the rectangle. Okay, that is the problem. For the examples you can find that like I am not going deep into the examples, but for the first case 1 comma 2 comma 3 comma 4, so this red portion, like this red square is the required rectangle, and there are four black cells in the rectangle, so answer is 4. Similarly, for the second case, this blue rectangle is a required rectangle, and there are total 7 black squares in the rectangle, so the total answer is 7. Okay, so for solving this problem, few tricks are required. So the first tricks will be 2D prefix sum. 2D prefix sum is the first required thing, and the second required thing is the 2D range query. So 2D range query and 2D prefix sum is required. So I will share the link of 2D prefix sum, and I will try to explain how we do 2D range query using 2D prefix sums here. So what is the problem? The most difficult part of the problem is that we have to do query on A. If we have to do query on P, it will be easier. We can do directly 2D range query, and this is quite known to us. Okay, so instead of solving for A, we will try to first solve for P, and then we will check how we can use the solution for P to solve for A. Okay, so first I will not explain the formula for 2D prefix sum, but I will share the link. Here you can say that this is the formula for prefix sum. This is nothing but prefix I minus 1 j plus prefix I j minus 1 minus prefix I minus 1 j minus 1 plus a I comma j. Okay, you can see how the formula comes. Now I will try to explain how 2D range query works. Like for, let's say we are given some point a comma b comma c comma d in P, how we can find the total sum for this rectangle. So you can for converting the problem into integers, you can consider character b as 1 and character w as 0, and the sum total sum in the rectangle will be the number of black cells. Okay, so here I am writing b is same to a, the character b is same to a, and character w is mapped to 0. Okay, so for 2D range query, let's say we are given some rectangle, and we are this point and this point, we have to find the prefix sum. Okay, sorry, the range, total sum in this rectangle, Okay, now this point, let's call this point as a comma b, and let's call this point as c comma d. Okay, now observe closely what we are doing. Let's say this part is nothing but what? This total part is nothing but our prefix sum of c comma d, right? This total part is nothing but prefix sum of c comma d, right? And this smaller rectangle is nothing but our prefix sum of a comma b, right? This prefix sum of a comma b. So for finding range sum, or we can say rs, of a b c d, what formula we can write is here the total this thing, the precd will be required to us, precd will be required to us, minus we will be deleting this part, right? we will be deleting some, let's say, let's take brown. So we will be deleting this part, we will be deleting this part. Similarly, we will be deleting this portion, we'll be deleting this portion. So the above portion is nothing but this will be something like prefix of a minus 1 d. Similarly, this rectangular portion will be nothing but prefix of c uh, b minus 1, c b minus 1. Now we will be adding this smaller rectangle, so it will be prefix of a comma b, prefix ab, right? This is the formula for range sum a b c d. So you know how to solve the problem for p. How to solve the problem for b? We'll be taking input as r1 c1 r2 c2, r1 c1 r2 c2, and we'll just do range query of r1 c1 r2 c2. But now, instead of for p, we have to find the solution for what? We have to find the solution for e. Now how to solve this problem for e, that is the interesting part. So let me clear all these things and try to explain the next part. So let's say this is our required area for a, and these are p's. Okay, these are p's. This is one p, this is one p, this is one p, and this is one p. So there are total, let's say, what are the number of p's here? The total number of p's here will be the length of the side of this. The side of this will be, let's say, the side of the array is n. So there will be n modulo p. Sorry, because n is the length of p, so let's take it as s. So s modulo n 1, and another one will be s modulo n. Okay, I hope you got it. There will be s modulo n and s modulo n. Okay, so sorry, I am considering this as square, but let's consider this as a rectangle. So let's say there are r rows here and c columns here. So the total number of p's in row wise will be r modulo n, and total number of p's in column wise will be c modulo n. Okay, now there will be some part extra here, there will be some part extra here, and some part extra here. Okay, so these are nothing but let's say there are we have, sorry, this will be not r modulo n, this will be r by n. Okay, there are r by n p's in row wise and c by n p's in column wise, and there are r modulo rows remaining here, and there are c modulo in columns remaining here. So here you can say there are uh, 2 into p number of columns and r modulo n number of rows. So the total prefix sum for this will be nothing but what we can do, we can do some prefix sum of what? Prefix sum of r modulo n, prefix sum of r modulo n rows and p number of columns into, there will be total c by n of all this. And similarly, plus for this there will be prefix of there will be r rows and c modulo c modulo n number of columns, and total number of these portions, this portion will be nothing but r by n. And there is also one smaller portion here which will contain r modulo n number of rows and c modulo n number of columns. So we'll be adding also prefix of r modulo n and c modulo n, r modulo n, c modulo n. So let's jump into the code, because I'm this part is not really uh, clean. So let's jump into the code. So here I am calculating the prefix sum. dp I plus 1 j plus 1 is nothing but prefix ij, and here I am calculating this portion, like the part I have explained here. So we are doing get of r2 c2. Get of r2 c2 is nothing but this part. Sorry, r2 c2 is prefix of cd, and r1 c2, r2 c1, and r1 c1, everything is according to this formula: prefix of cd minus prefix a minus 1 d minus prefix of cb minus 1 plus prefix of ab. Okay, let me explain this again. So we are just incrementing r2 and c2. So get of R2 C2 minus get of R1 C2. So R2 C2 is nothing but prefix CD. R1 C2 is nothing but prefix A minus 1D, because we have only incremented R2 and C2, not incremented R1. Okay. And similarly, prefix of CB minus 1 is nothing but get of R2 C1, plus prefix of AB is nothing but get R1 comma C1. Sorry, I have made one mistake here. This will be prefix of A minus 1 B minus 1. Now let's jump into the get function. The get function is similar to the thing I have explained here. There are number of p's will be in the row wise, and there will be c number of columns, sorry, c number of p's column wise. Okay, I hope you got it. So I by n and j by n will be the value of r and c, and the total number of p's will be r into c. Now this pi and pj is not required, you can ignore this. Now we are doing the remaining number of rows and remaining number of columns here. So we are doing total into dpnn. So dpnn will represent the sum of p's in p, plus we are doing r into dpnj. I have already explained here, we are doing r into dpnj, this part. And similarly we are doing c into dpin, this part. And we are doing this thing, prefix of r modulo n c modulo in here, dp of ij, because we are already doing I modulo n j modulo n, and we are changing the value of I comma j. So this problem is quite interesting, and you can learn a lot of things related to prefix 2D prefix sums and range query on matrix here from this problem. So I found this problem literally really interesting. And I think the code of the problem is also not very difficult, just you have to know that how these things work. So I will provide the link of the prefixum editorial, like prefixum article for geeks for geeks, and link I will provide also link of the code, my code, in the description box. If you have any query in any part of the code or any part of the explanation, you can write in the comment section. I will try to reply each and every comment. If you find this video helpful, please like the video and subscribe to my channel. Thank you.